All right. Can you see my screen? It's Gladys. I only do the chat box also if maybe I don't know for let me check if I can let's see. Okay. Yeah, you can mute now. I think you can mute now. Can you see my screen? You can try. Okay.
Yes, I can see the screen.
All right, all right, all right. Okay,
Yes,
so
I can see the screen.
right.
Can't I rotate my phone so I can see? Is it possible for me to rotate my phone?
I guess.
Can you hear me?
Yes, I guess you can. I guess you can. I think you have to turn on your auto
Although I
repeat.
can, although I can still see it. Okay.
I think you have to turn on
Yes,
your
let
auto
me
repeat.
try. Okay, yes, this is, yeah, I've done that. This is very good.
All right. All right. So basically, we're looking at kinematics. If you check the YouTube page, I already have a video already made
Okay.
for kinematics, and I will just start with this. Okay. So where's my pen? This is a Zoom free class, so it should not last up to an hour. Time is limited, but
Okay.
it's free section. So when it comes to kinematics has to do with motion. So we have one-dimensional motion, we have two-dimensional motion, and we have three-dimensional motion. All right. Okay. Now, the first thing to know about motion is that when you're talking about motion, motion has to refer to, you can always check that video. The video I uploaded on the YouTube has the introductory part. So what it's just like rehearsal. When you talk about motion, you're talking about the change in position to another position under the influence of what? Time. Do you understand? If you are at this point in time, and in the next few seconds, you are at this point, time involved, all right, with that changing position is motion. Do you understand? All right. Now,
Yes.
when it comes to motion, there's one of the basic things after that we call distance and displacement. These are some very basic things. And displacement, distance and displacement. So what's the difference? The difference here is that, do you know the difference?
Yes, I know the difference.
Okay, that means
Okay, the only difference I know is that distance is a scalar quantity, while a displacement is a vector quantity.
all right, all right. Let me make that very practical. If this is your home, all right, and you're going
Okay.
to the library. Now, when you move like this, sometimes your route is not always straight, it's always curvy and all, and you arrive at the library. This is now. So the distance can be, let's say, 15 kilometers. All right. Now that is distance. You can now if you move from A to B, you've covered 50 kilometers. When you move from B back to A, you've covered another 50 kilometers, and that gives you a total distance of what? 30 kilometers. Do you understand?
Mm.
But when you're talking about displacement, you don't consider this curvy line, this curvy route. When you're talking about displacement, you just measure a straight line straight to your position. So the displacement between from A to B is what? 15. Now, here's the difference. The difference is that if you observe, this is a straight line in a what? Specific direction. Do you understand? A specific direction. It is direction of west, sorry, east to the east. Unlike this curvy line, it's not actually a specific direction. Do you understand now? So while your distance is 50 kilometer for distance is just magnitude. When you have a distance of 15 kilometers, right? That's just magnitude. But when you have displacement of 50 kilometers, it is not just magnitude now. It's both magnitude and what? Direction. Do you understand? So while your distance is 50 kilometers, right? That just magnitude. But when you have displacement of 50 kilometers, it is not just magnitude now. It's both magnitude and what? Direction. displacement of 50 kilometer what? East. Do you understand now? Do you get it? What if you had an object this way? Let's say you had an object here, and let's say you go to the market, and your market is this direction. Now your library is over here as well. For example, now, right? Okay, let me do this rather. So let's say this is the market, all right, and this is the library. From here to here, straight line. Let's say the distance from here to here in a straight line is 10 kilometers. And while the distance from A to B to a library is 15 kilometers. All right. That's now this straight distance from A to B, from A to M, you observe this direction. You to do your four cardinal points. This A to B, this A to M you see right here, falls around this place, right? Isn't that so? And this is what your north, and this is what your east. So this is your what? The northeast. You can say that the displacement from A to B is what? 15 kilometer, sorry, 10 kilometer rather. Northeast. Do you understand this now? Are you there? Can you hear me? I want to be sure you're there. Can you hear me?
Yes, I can hear you.
Right. Okay, so now, but now that's the difference between distance and displacement. Okay, let me give you an example. An example here. I use this textbook. Okay, let me show you something quickly, very quick. Now, this is what you can see 1D. Look at the what am I like 1D motion, like the one-dimensional motion. The question will always be different from a two-dimensional motion. Can you see? So there's a way to treat all these things. They also have for three-dimensional motion. Can you see? This one you see here is a three-dimensional motion. It has other axes involved in it. So, but I want to just restrict myself to just one-dimensional motions, just to get into all this. Let's take an example here. That displacement. Now, if you observe the displacement, this question I'm about to bring here. Hey, I'm not here. Sorry. All right. So, where is it? Oh my God. All right. It's down. I'm trying to get it. Where is it? So, this example. All right, look at this example. A cyclist rides 3 kilometers west, then turns around 2 kilometers east. What is her displacement? What distance does she ride? What is the magnitude of her displacement? We're told that it went what? Let me write my charts here. I thought she went 3 kilometers west. Then she turns around and rides 2 kilometers east. We're told that what is her displacement? Now, if you ask us a question, the total distance traveled will be just 3 kilometers plus 2, which is 5 what? Kilometer. But when you're talking about displacements, remember, just always put your focal point at your mind somewhere. So imagine the starting point. She's going west, that means she's going this direction. All right, 3 kilometers. But she turned around and went backwards 2 kilometers east, trying to east. So east is this direction. That means if we look at this whole thing, if you started from this position and you went 3 kilometers, all right, and you came back by a distance of what? 2 kilometers, it means that you are back, you're almost back to your starting point. So the distance from this point, all right, this point now to this point you started, all right, that's your displacement. Because displacement is what? Is the change of what? Position. Okay. So that would be 3 minus 3 kilometers minus 2 kilometers, and that's what? 1 kilometer. But now we want to give it direction. Do you understand? So to take it a bit further is that because this was this is your cardinal point. Can you hear me? I want to know. I think the way I set this thing, it stops people from using themselves. Let me check this out. I'm trying to see if I can get your message.
Yes, I can hear you.
Are you getting this?
Yes, I'm getting it.
Right. So now, because we actually we're actually moving in the west direction. We know that on your cardinal point, here is what? Here is plus, here is plus, right? This plus y, this plus x. This is minus y, and this is what? Minus x. So if she's going west, this is west, right? This is north, this is south, and this is east. So west is what? Negative. That means she went minus 3 kilometers, all right? West. Then she turned around, right? To go to the east. And when you're going to the east, this is what? Positive, right? That will be plus 2 kilometers east. What does that mean? Minus 3 kilometers plus 2 kilometers using what? Still minus 1 kilometer. Now, can you see that there's actually a difference between this one here? This one I did here is quite different from this because this one has only magnitude. All right. But when I put minus in front of this one, it give it a direction because by seeing this, it tells me that where this lady is located right now, she's located at the -1 of this chart or this cardinal point, -1 kilometer. So it means that she's still in the west. That means what this thing means that if this was our starting point, she's still in the direction of west, but at a distance of what? 1 kilometer. You understand? If I left it without, if I assuming I wrote because assuming I left it at just imagine I left it as just 1 kilometer, it would mean that she's in the east direction. Why? Because you have positive for what? The east. You understand? But we have to put it what as negative, so that it's what in the west. You get now. Going to the next question there is that where is it again? Okay, yeah. The next question now in that same, can you see that this will happen? Now, what is the magnitude of our displacement? Exactly. So the magnitude of our displacement is just 1 kilometer after calculated, but we have to put the minus to show what the direction we get now. All right, I want to look for another example as quick as possible. All these ones are similar examples. They are very, very similar to the. All these ones are like similar questions we can solve, like similar to the example. I want to give you another one. I think there's another question on displacement. I would have given you this. This one would have been very nice. This one, but this one is like a three-dimensional scope, and I don't really want to enter it yet. So I just want to just start gentle tonight, then take it off for the next time. Is there any way I can simplify this for you right now? looking at our time. What time is almost gone, but I don't, let me keep it simple tonight. So you can just have like now when it comes to speed and velocity, let me try and wrap this up. So speed and velocity is quite different. Just the way you have okay, let me hear you out. Can you unmute yourself? I want to be sure this thing is it's not restricting you. Can you unmute yourself? Hola. Oh, okay. Try and unmute yourself, please. Okay, great, great. So that's how it works.
It was saying admin is not allowing
Yeah, I'm not used to doing like that.
participants to unmute themselves. Yes, but I was listening to what you were saying.
Did you get?
But there's something,
Yeah.
there's this part you said, there's this part you said, um, yeah, go back to that your screen. Yes,
Okay.
yes. This part you said -1
Right.
is the displacement. I thought the displacement is just supposed to be 1.
Okay. That will be the magnitude. But because we want to give you direction, remember displacement is what? It's a vector quantity. And what's a vector quantity? A vector quantity has both magnitude and direction.
Yes.
So if you write it as just one, it's not totally correct because that's the magnitude. But we should not forget that it has about a direction.
Okay.
That's why we have to put the -1. Okay, let's take an exercise from the textbook. It might just like solidify everything for you. Look at this one. Can you see my screen? You see, let me zoom it.
I see the screen very well.
What's happening here? All right. It says on an axis in which moving from right to left is positive. These guys are trying to use graphs. Yeah, move from left to right is positive. We know that. We know that.
This one I'm seeing the YDS.
Where is it?
No, the two-dimensional. This I was seeing something like the YDS.
Oh, okay. Let me check this one out. Number two. Tiana
Okay.
jogs 1.5 kilometer along a straight path and then turns and jogs 2.4 kilometer in the opposite direction. Can you see now?
Mm-hmm.
Then now she then turns back and jogs 0.5 kilometer in the original direction. Let Tiana's original direction be positive direction. What are the displacements and distance she jogged? Let's try to solve these two questions. This meeting might end very soon because of the fact that it's a free section. So I will have to create another link and another meeting code and give you on the group chat. Okay. Now, let's pick number 2. We're told that this lady, what's the question again? She jogs 1.5 kilometer in a straight path. Let's take it out. In a straight path. Let me mark out this area. We're done with all this section. Or in fact, let me make a new page. In a straight path. 1.5 kilometer. Now, we're not told whether it's east or west. So just follow the question gently, right? Then we're told that then now and then turns are and then turns, all right, and jogs. She turns and jogs 2.5 kilometer in the opposite direction. That means we'll go backwards again, still on that same lane. We'll go backwards because 2.4 kilometer is higher in magnitude. That's why I drew the line longer than what 1.5. So if I was to redraw it again, I could just make my 1.5 like this. All right. Then my 2.4 kilometer this way. because it's opposite in the direction. And I made it 2.4 longer because it is higher in magnitude than 1.5. Right. Then she then turns back and jogs 0.7 kilometer in the original direction. So what was our original direction was that this to the left, the right side was our original direction, right? So she turned back again and jogged what 0.7 kilometer. Now what were we asked? We were asked that let Tiana's original direction be the positive direction. Do you know what they mean by this? They are letting you know that her original direction is what? In the east. Because, let me show you. Remember I told you that when you have your cardinal point, this is your cardinal point, right? North, south, west, and east. This is what? Plus x plus what? Y minus what? Y minus what? X. So if we are told that let her what? All these things are just keywords, right? Let Tia's original direction be the positive direction. So they are giving a hint that our original direction was what? In the positive side, which was east. Now, let me tell you the implication of this. Now, if you observe, I drew mine this way, right? You could come and say, okay, let me draw my own this way. Let us say that our own direction was what? The original was what? Now you could draw your own this way. Let's say we had about 5 students in the hall and they had this exam question. The first student would have drawn his own the way I did my own. You might come this one and say, okay, her direction is towards the left. And when she turned around, went like this way. All right. And she turned back again, 0.75, 0.7 kilometer. You can see this is reverse from what I drew, right? Right? Do you understand what I'm saying? Can you hear me? Uh, I need a response. Yeah, you can please unmute. I want to know if you understand what I'm saying.
Yes.
Okay. Now,
Mm.
so imagine someone drew his own this way, and another person drew his own this other way around. But if you had paid more attention to the question says what? Let Tia's original direction be the positive what? Direction. By this, you are being told that it must not be in the negative direction. It has to be what? Our original direction has to be what? In the positive side, meaning that it has to be what? In the east lane. So it means that you will clean all this you drew here. You will clean all this and redraw it and write and do it like this. Because the 1.5 kilometer was our what? Original direction. Can you see now? East. Turned around what? 2.4 kilometer. And then turn around what again? Back again, 0.7 kilometer. Now what's the question? We're told that what are the displacements and distance she jogged? Very straightforward. So this was our starting point, right? Isn't that so? So you can help yourself by drawing a demarcating line. Okay. Now, our original direction was 50 kilometer to the east. Now you do 1.5 kilometer minus this 2.4 because she turned around. That'll be what? Let me check it up on the calculator. One point five minus 2.4. That is minus what? Minus 0.9 kilometer. What does this mean? This means that at this point, this was the first movement, right? And this is what? The second movement. At the second movement, she was, it meant that she was 0.9 kilometer away from her starting point to the west direction. That's why there's this minus there. Can you see? Now, but we think that she went back again to in our original direction. That means she now went back in the east direction because we're told that our original direction is what? Positive. Our original east is what? The positive direction. Then what we'll do again is that we'll now add that 0.9, that minus 0.9 plus 0.7. Why is it plus? Because she is going in the positive direction. If she went further in the west or in the negative, we would have used minus. Do you understand? Okay. So what does this imply? That 0.9 plus 0.7 is what? This is minus rather. That'll be what? Minus 0.2 kilometer. Now we're asked, all right. This is for what? The third movement. We're asked what? What is the question? We're asked what are the displacements and distance involved. First of all, what is distance? Distance is 0.2. Okay, wait. First of all, what is displacement? The displacement, for that distance, I don't want to get it wrong. This is quite straightforward. Displacement is what? 0.2 kilometer west. Because why? From the calculation, we have what? Minus. All right. Then if there was no minus, it would have been east. Do you understand? Good. All right. What else again? The distance would be what? Now I don't know if they are asked for the total distance. If it was the total distance, that would be 1.5 plus 2.4 plus 0.7. But they just ask for the distance, so it's probably the distance is just 0.2. Oh, I'm making a mistake here. This should be displacement, sorry. Sorry for that mix-up. This is displacement, or distance. Displacement has direction, remember. Distance does not have what? Direction. Now, what is distance? The distance is what? 0.2 kilometer. Don't put west because distance does not have what? Direction. All right. But if we're told to find the total distance traveled, you would have just done what? You would have added everything together, 1.5 plus 2.4, and let's check it out. Let's check it out. Okay, 1.5 plus 2.4 plus 0.7. That gives 4.6 kilometers. That would have been the total distance traveled, but we just only ask for distance, not the total distance. So let's check what we have as the available answers. Okay, now, did you observe that among the options, our answer lies here? So which one will be the correct one? A is what? 4.6 kilometers. Why are they missing this enough? This is being mixed up because, oh God, I think we have about a few minutes left. Let me create. Can you please unmute yourself? I want to. Okay, I will send you a voice note to explain it properly. But I think it should be our answer because our answer was what? 0.2. Minus 0.2 kilometer was our displacement, right? Then when I calculated the total of the whole distance, we had 4.6. So this should have been our, this should be our odds. This should be our answer. This should be our answer. You understand? Could you please unmute yourself? I want to know if you got all this correctly. Good. Okay, B is our answer, not A. Exactly. Look at B is our answer because displacement is what? 0. Minus 0.2. Could you please unmute? I want to know if you following. I want to know if you understand all this. Um, yeah, you can unmute yourself, please. No, are you there? Can you hear me?
Okay, I dey come. I dey meeting. I dey come.
All right. Did you understand what we just did now? That is, I want to know if you're following. The meeting is about to end. At least if it's the only thing we did today, that's nice. Okay, we have 8 minutes left. So we need 8 minutes left. We can ask a question before the class ends. Hello, can you hear me? Did you
So,
please? Yeah. So did you understand what we did so far? Hello. The answer is
my network. Can you hear me? My network keeps cutting.
oh.
I'm coming. Just wait. Just wait.
All right. Hey. So of these files. Okay. All right. The video is recorded and I'll put it on YouTube. I'll upload it on YouTube. Right. Mhm. Let me see what's going to happen here. Let me show you the video I made some weeks ago concerning motion kinematics. All right. So when you come to YouTube, you just search for TRiCiTY Academy and can come to this section here. Come to playlists. When you come to playlist, you find this video, one dimensional motion. You can always play it to get. I actually use softwares to explain the whole thing. Yeah, softwares. Yeah, so do well to like it and subscribe to the channel. All right. Oh, that's true. Okay, okay. Thank you, 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 thank you. Thank you, thank you, thank you. In hello Gladys. The meeting is about to end. All right. I believe I'm out of the meeting already. So we're ending it now. Ending it now. Okay.